Hello, Professor Tran. My name is Brandon Essebag, and this is my lab partner,
Merrick Pope.
So this week we worked together on the final logic lab. This monster took like 6 hours of our time to make. So this is it. It's quite a mess. Very brief explanation of why it's such a mess. The main clock runs at 10 hertz, and then there's a clock divider that produces a 1 hertz output. So that drives the timer that determines when the system resets, but the 10 hertz determines when the latch is set so that you can, it basically makes the window for people hitting the button and tying very small, 1/10 of a second, so it's more realistic to a game show. And the chip for this to the right is an adder, so we can actually, thank you, turn this on. And it seems to find a random number the first time you turn it on, so we can actually just, oh, the button came out, there it goes. We can turn that on, there it goes. So now it's at 0, which is where it needs to be. So the yellow lights for each button is the internal, it's the internal state of the flip-flop, and then the green button is if it wins. So we can actually hit a button, and we will see that it counts up to 10. And then they reset. We could show you that the other button also functions this way. And can you please turn the clock to manual mode? Oh. It's this resistor, it keeps coming out. Or is it this? Okay, I guess we don't get manual clock. Something's loose. If I'm really quick, there you go. If you hit them both within 1/10 of a second, the two internal states turn on, but the outputs don't because neither state wins. And that is our game show circuit. Thank you, Professor.